This is Anita Wood, and welcome to the topic snippet video introducing a tool for developing our logic called flowcharts. From your reading, you recognize this image. Flowcharts are one of the most common diagrams on the planet, used by both technical and non-technical people in various fields. Their use started in the 1920s, where they were used to document general business processes. In the 1940s, they started to be used to develop computer programs. Flowcharts can help organize big picture thinking and provide a guide when it comes time to code. We know they consist of numerous shapes and arrows that define the flow or sequence for the flowchart. The one thing flowcharts do best is to show the way the logic is organized, and it allows you to visualize the execution of that logic. When creating a flowchart, you draw geometric shapes around individual processes or statements and connect them with arrows. Here's the first symbol you read about, the parallelogram. What does this symbol represent again? The parallelogram is used to represent input and output. You may not always need to get data from the user, but you will certainly need to output your results. Here's another symbol, the rectangle. What does this shape represent in the flowchart? A rectangle denotes processing, and in programming, there is going to be a lot of processing getting done. So flowcharts are going to have quite a few rectangles. One thing to keep in mind when showing processing, we do not want to combine processing steps in one rectangle. When we do this, it makes it very difficult to make changes, like moving things around. So keep the processing symbols simple and have them reflect only one process. So we have the symbols that represent everything we discussed when creating an IPO chart. So if you start with the IPO chart, you can easily transition into defining the processing further by using these flowcharts. But let's add another shape to our library, the diamond. The textbook doesn't discuss this shape in detail right now, so I want to touch on it quickly, just to help you when you see it in your reading. Diamonds are going to signal two different types of flow in our flowchart, a decision and a loop. Decisions are so important, we have an entire chapter dedicated to them. For now, I know you're comfortable with the concept of making a decision based on the results of a test. Every day you ask yourself, do I have any homework I must complete before tomorrow? If the answer is yes, I know you hunker down and start working on the homework. If the answer is no, many of you turn on your PlayStation and become immersed in the land of between until hunger pains get your attention. Just a few details about this symbol. Standard practice has the yes results coming out the right, most side of the diamond, and no at the left. We'll see in the next chapter, the diamonds will also denote a loop, and for looping, we utilize the bottom of the diamond. You may think these differences are subtle and not important, but you're going to soon find out they may be subtle, but they are really important. So when representing a decision, only use the sides of the diamond. When representing a loop, you use the right for yes and the bottom for no. The flow of a flowchart is represented by lines with arrows. Now, there are two more symbols that denote the start and stop of the chart. You may think this seems unnecessary, and for a small flowchart like this one, you're going to be right. But this is not the norm for the size of a flowchart. Some are pages long. So being able to determine the start and end with these flowcharts would be difficult without these terminal symbols. Now, there are more symbols within the flowchart dictionary, but for our needs, these are the few symbols that we will be using, and these are going to be enough. Based on our new understanding of what the various symbols represent in a flowchart, let's see if we can make a general statement about what problem this flowchart represents. we know to start at the top with start. Now I'm going to help you with the first processing box because we don't have any understanding of the concept of variables yet because we haven't discussed them. And we haven't really looked at the fact that they've got to be declared. That's next week's class. The first processing box here is where we declare the variables we're going to use. So here's the variable count. Ignore the word num and concentrate on the fact that count is initialized to 0. Initializing means set it to 0. The next step is a diamond. Think about what does the diamond represent, and can you see and figure out the test that's occurring here? The statement count less than 4 is testing the current value of count against the number 4. If it's less than 4, the logic flow exits the rightmost point of the diamond. If not less than 4, the logic drops out the bottom of the diamond. Based on my previous discussion, since there's something dropping out the bottom of the diamond, this decision is used for a loop. Remember, I said decisions are going to be covered in an entire chapter in our book, but I think you're going to be able to get the understanding of what's happening here. So, count is initialized to 0 in the declarations processing box. We see the flow of the logic going to the right because count 0 is less than 4. Now, there's an I/O step and another processing step. I'll give you a few seconds to think about what the logic is accomplishing here before I give you the answer. The output symbol tells us the word hello will be outputted. The next symbol is a processing symbol, which adds 1 to the current value of count. 0 plus 1 is 1. That statement may look odd to you as far as the structure, but that's okay. We'll cover how to read and write this type of logic later in this chapter. We follow the arrow or flow back up to the right and to the line before the decision symbol, and continue in the downward fashion as depicted by the arrows. Here, we're at the decision symbol, but this time count is 1. I'm sure you're starting to see the pattern here. We test count to see if it is less than 4. If it is not, we print the word hello, add 1 more to the count variable, and around we go again. And this continues until the count is no longer less than 4. I'd like you to take a few minutes and continue walking through this code. This time, keep track of the number that is in count and when the word hello is printed. I started you off here by showing you some of the information you should be tracking. My question to you is, how many times does the word count get outputted? Stop the video and try this out on your own. I worked it out. What you see here is what will be called a desk check of the code. I didn't compile or run the code. I just used the flowchart and wrote the results of the various processing and tests, just like the computer would do. Let me quickly go through the desk check. Warning, this type of activity can and will be tedious, but doing so is so important in our ability to understand or test the logic. So here we go. We'll just start at the very beginning. This is where we set count to 0. We come on down, do the test, count less than 4. Yes, output, hello. Count is updated and incremented by 1. So count plus 1 is 1. So back to the top, around we go. Count less than 4, we're right here. I'm going to stay over here. You follow with your eyes using the chart. Count less than 4, well, count is 1. So yes, output, hello. Count is going to be count plus 1. Now it equals 2. Back to the top. Is count less than 4? Well, it's 2. So yes, output, hello. Count is count plus 1. So 2 plus 1 is 3. Back to the top. Count less than 4? It's 3. Yes, output, hello. Count equals count plus 1, 3 plus 1, or 4. Back to the top. Count less than 4? 4 is not less than 4. So no, it falls out the bottom. I hope my desk check agrees with yours. And if you think about it, hello is outputted 1, 2, 3, 4 times. So that concludes this topic snippet video on flowcharting.